everyone. A particle moves according to a law of motion given here. T is positive or equal to 0. If it's equal to 0, that means initial time. It's measured in seconds, and S is measured in feet. So we're going to find the velocity at time t and the velocity after 3 seconds. When is the particle at rest? When is it moving in a positive? And we'll also look at negative direction. Find the total distance. Draw a diagram based off t, basically. Find the acceleration and graph. I graph this with the calculator, but you need to just make sure your window is set correctly. So basically, let's do the first part. We find the velocity. So for that, we're going to get the velocity of t equals f prime of t. So when you take the derivative of this, you're going to get 3t squared minus 24t plus 36. And this is in feet per second. Usually we use meters. All right. What is the velocity after 3 seconds? So basically you're just plugging in 3. So when you plug in 3 for our velocity function, you get 3 times 3 squared minus 24 times 3 plus 36. That's going to give us 27 minus 72 plus 36. So this is going to equal negative 9 feet per second. So that's the velocity after 3 seconds. Now what we want to do is, when is the particle at rest? When the particle is at rest, v of t should equal 0. We also have v of t equals, I'm going to go ahead and factor out of 3, so that would be 3 times t squared minus 8t plus 12. Since these two are the same, because we want it at rest, set it equal to each other. You don't really need the 3, but we'll go ahead and put it. And find when t is at rest. So this is going to be t minus 2 and t minus 6. So when you set this to 0, that means it's at rest when the time is at 2 and our time is at 6. All right? When is the particle moving in a positive direction? So I'm going to copy t minus 6 over here. So we have, if it's positive, v of t is positive. So we have 3t minus 2, t minus 6. That must be positive. So I just do a little line graph here. And I'm going to put 2 and 6. And usually start at 0 for time. That doesn't really matter. We've got to figure out if it's positive or negative. So if I plug a 1 in here, that's going to end up being negative. And if I plug 1 here, it's negative. So this, from 0 to 2, it's going to be positive. Because you have 3 times a negative times a negative. So that's going to equal positive. Now let's pick any number in between 2 and 6. See what's going on there. So let's pick 3. So 3 minus 2 is positive, and 3 minus 6 is negative. So positive times a negative is going to be negative. And then let's pick another number. If we plug in 6, we get 0 because that's where it's at rest. Remember, at rest, it's t equals 2 and t equals 6. So if we plug in 7, we're going to get positive and positive, so that's going to be positive. So t is, the velocity is, the particle's moving in a positive direction. when t is less than 2 and when t is greater than 6. T is negative here, so it's negative between 2 and 6. All right, now we're going to find the total distance, and we need to remember these here. So I'll have to go back. Find the total distance traveled during the first 8 seconds. So what we're going to do is we're going to use our intervals from 0 to 2, 2 to 6. This is where it's positive, this is where it's negative, and from 6 to 8, because we want it for the first 8 seconds. All right, so all you do is you're going to do f of 2 minus f of 0. So when I plug in 2 into this, I'm going to get this equals 32, and I plug in 0, I get 0. So that equals 32. Now, let's do this one. So we have f of 6 minus f of 2. We're doing absolute value because distance is always positive. So f of 6, if I plug in 6 in here, you're going to get 0. And then we already did f of 2. F of 2 was 32. So you subtract that. Absolute value of negative 32 is 32. Now we're going to do from 6, absolute value of from 8 to 6. So for 8, if you plug in 8 into this, you're going to get 32. We already know f of 6 is 0, so that equals 32. So the total distance equals 32 plus 32 plus 32, and that equals 96, and that's going to be in feet. All right, so now what do we have to do for G? We got to do the diagram. So let's do our little diagram. So basically what we had is it's positive when t is, and we're going to start with 0 in between 0 and 2, and then it's also positive from, what was that, 4? How is our diagram going to go? The diagram to show the motion of the particle. So basically what we want to do is start down here. I'm going to go way down, and I'm starting at 0. This is my S line. So when t is 0, I plug in 0 in here, and my S is going to be 0. Now we're going to go all the way down to this 1, 2 for the t. So we go this way. This is positive. But at 2, remember t equals 2 and t equals 6. It's at rest. So what you do is you come out here, it's at rest. So this is at t equals 2. And at t equals 2, S is going to be 32. So this is really 32 here. All right, t equals 2. Now, come back around, and we're going to go negative. So we're going to come back up to here, go negative. Now, this was positive. At rest, I'll put a little dot there. And then we're going negative. So, here we're back at S equals 0 when t equals 6. And we already knew this part, because that's how we did the at rest thing. All right, and then we're going to go up, put a little dot here, and go back around this way. We're going to stop at s equals 32. So at s equals 32, our t was 8. We're doing the first 8 seconds. So, and this is going positive. So we had our s at 32 to 0. And that's kind of how you do the diagram. The vertical lines are at the at rest part. Now we have to find the acceleration at time t and after 3 seconds. So basically, the acceleration, let's write the velocity down. So the acceleration of t is just the velocity squared, the derivative of the velocity. And that's going to be 6t minus 24. So when we want to look at 3 seconds, we just go a of 3 equals, and you just plug in 3. 6 times 3 minus 24 equals negative 6 feet over s, and then you divide it by s again for since you're doing the derivative, second derivative, so that's going to be negative 6 feet over seconds squared. All right. Now the graph I just did in the calculator, and just remember the acceleration was linear. So when you're doing your graph, always look for your y-intercepts. So when I did my y-intercepts, I didn't look at this very close. This should have been, I'll just put this as negative 24. So the acceleration is your linear line here. And then I looked at my y-intercepts for the other two. My particle graph is here, my position graph. And I just sketched the graph. The main thing is I had to look at my y-intercepts, and then for your x window, you're going from 0 to 8. And that's it. Thank you. Have a nice day. Bye-bye.